Today we're looking at Glencoe Accelerated Math, Lesson 9.3, on the constant rate of change and slope. When we worked with proportions, we talked about the fact that we could have a unit rate, which was the same as our constant of proportionality, which was the same as a rate of change, which was the same as a constant rate of change when that rate of change did not alter. And then we also talked about the fact that later on this year, we would call that constant rate of change, all those things, we would call them the slope. The difference between slope and a unit rate, or the slope and a constant proportionality, is that a slope can exist if we don't go through the origin. So before, when we were talking about all this, our graph had to go through the origin for it to be proportional. In this, our graph does not have to go through the origin, but it is going to represent a constant rate of change. So, if we look at example 1, example 1 gives us a time and it gives us a distance. So we need to know, what is the relationship between that change in distance and that change in time? Okay? If I was going to draw a graph, can time be negative? No? Okay. Can distance be negative?
Yes. No.
You went a negative 2.3 miles.
That means you went backwards.
So, that means that we are only working in quadrant 1 of a coordinate plane. But when we graph these things, I need to know, to set up my problem correctly, which is the dependent variable, which is the independent variable. This is something that was talked about in science. This is something that was talked about with our dry mix. So would we call time our independent or our dependent variable?
Independent.
Time is independent, so that goes on my x-axis. So that means that the distance is the what?
Y-axis.
Right, which means that my y value will be the distance. Okay. When we look at our data, when we find the slope of a line, which is that constant rate of change, we are looking for the change in our y value divided by the change in our x value. Now, I don't want to write out the change in y and the change in x every time, so mathematicians decided that we would use one of our Greek letters to be able to represent the phrase change in. What? Nope, not a Roman numeral, a Greek letter, not a Roman number.
Pi.
Not pi. We use the Greek letter delta.
Oh, I know what that is.
What is it?
That thing.
That-
I've seen it before.
Okay.
That's how I know what it is, you know? The quotes, you know? Yeah.
That's a triangle.
That looks like a triangle, but that triangle is actually
Delta.
the Greek letter delta.
What does it
And
mean?
delta means the change in. So you can see, we use delta to represent the change in. So if we would see something like triangle y over triangle x, that means we're looking for the change in our y value divided by the change in our x value. And we say that as delta y over delta x. Alright? We may have also heard that called the rise over the run. The The rise tells us where our y value is, correct? Yep.
And the run.
And the run goes side to side. So this is another way that you might have heard this referred to, where the rise is our y value, the run is the x. Okay? So when we look at that table on page 396, what is my change in y?
12.
Which one is it?
12.
The change in y is going to be 12?
Yeah.
Okay. What's my change in x? 2. Can I simplify 12 over 2?
Yes.
What do I change that to?
Oh.
6. Okay, so that means that my constant rate of change, my slope, is 6. I have good news for everybody. The good news is, because we are working with relating an x to y, if we end up with a number that's not a whole number, leave it as a fraction. Leave it as a fraction. If our answer ends up being an improper fraction, you can leave it as an improper fraction. Don't convert it to a mixed number. Okay? Because our slope, let's say that our answer was 9/7. If we were told to graph that slope, we can, by seeing 9/7, we know that we go up 9 and we go over 7, right? From one point to the next. Easy peasy. If we have 1 and 2/7, then we've got to do more multiplication and more calculation. Let's not do that. Okay? So we're going to keep our slope as a fraction. Can we see it as decimals? Absolutely. But we don't want to. Missing mark? Bottom block bit. And if we end up with an improper fraction, we're going to leave it that way. Okay? Questions about that example?
We don't graph that one, right?
That's it.
Yeah.
Right, slope. Slope is the number that represents the steepness of a line.
What?
The equation y equals x gives you a slope of 1. That's kind of, slope of 1 produces a 45-degree angle. Alright, so that would be a slope of 1. Anything between 0 and 1 is going to be not so steep. Anything greater than 1 is going to be really steep. Anything that's negative is decreasing. So instead of our line going up, our line would go down.
Okay.
Okay?
Yes.
So that is not the graph of.
We don't have to draw the little finger, right? Good.
No, I drew the distance time coordinates so that we could make sure that we had our x value and our y value correct.
So which one do
When we look at the table.
top?
Y value. The y value has to go on top. Okay? Alright. If we look at the bottom of page 397, it gives a concept summary box and it tells us that if our slope is positive, then that means that our graph is increasing and our line goes up.
Yeah, you still have more words into it.
I did.
Oh my gosh, you can
Money
explain
decreases
stuff further
every day.
forward.
I can!
Oh my goodness. You get
If-
an A. Let's go.
Thank you. If our slope is negative, then our graph is decreasing. That means it is going in a downward direction.
I guessed that.
Okay. Now, it is possible to have a slope of 0.
Just go straight.
It just goes straight across. Now, ladies and gentlemen, We don't see that very often.
We don't get the easy stuff, is what you're saying.
Actually, the reason why we don't is because if we have a line that has a slope, if we have a line that has a slope of 0, our equation would be something like y equals 4.
First.
So that's not an equation, that's a solution. But we would graph that solution as a line.
This is easy work anyway. Tell me.
Exactly. So those aren't very common. It is possible to have a slope that is undefined.
What is this? Oh my god.
Because that graph is not a function.
So it's just no function.
Right. So if we had something like a line that goes straight up and down, you can graph that, but it doesn't have a slope because it's not a function.
That's what they have to say, you know?
Right. It doesn't pass the vertical line test. Okay? Everybody understand that?
Yes, ma'am.
Which part?
You had me at home.
Okay.
This is Glencoe accelerated math.
You lost you there.
Lesson 9-3, page 9-396.
You don't even know the page.
Yeah, I know.
So, what do I need to go back and go over? Okay.
Miss One.
So then let's look at this in the context of example 3. Okay? Yes, sir.
One more question. So the y value is one under like that
Is
part.
this where you graph this?
Generally, when you have a table of information and a table of data, generally speaking, your x value will go on top, your y value will go on the bottom. When we are calculating the slope, the change in y needs to go in our numerator, the change in x in our denominator. So you're not putting your y value and your x value in there and then dividing. You need to find the change in the two. So what's the difference from one point to the next? Okay? I'm sorry?
One's name is Jeff and the other one is Bob.
No, we don't have a Jeff and a Bob. We have a delta y and a delta x.
Well, you're kind of picky. That's their government names, you know? Their
Oh.
nicknames are Jeff and Bob.
Okay. Let's look at example 3, please.
So you graph it, right?
In example 3, we are given a graph of a line. I'm going to look at example 3b. Because I believe that we live in a 4-quadrant world. And so let's look at a 4-quadrant graph. Alright? So, in that example, we are given 2 points. We're given the points 2, -2, and -4, 2. Hold on. So what we have to do to find the slope of that line, we need to find the change in y and compare it to the change in x. So if I go from 2 if I look at my y values first, I have a 2 and I have a -2. I need to find the difference between those two values, so I subtract them. 2 minus -2. And I'm going to divide that by the change in my x's, which are -4 and 2. You see it written in your book as y1 minus y2 over x1 over x2, correct?
I just skipped over that part.
Okay. This says we're finding the change in our two y values. So does this.
Oh, okay.
And this is what that looks like in our example. this says we're comparing the x value from my first ordered pair to the x value of my second ordered pair, which is the same as saying we're looking at the change in our x value, which is this. Okay? 2 minus -2 gives us
-6.
4.
0.
4. If you have $2 and I take away $2 that you owe me, you have $4.
Whoa.
So like
What?
Oh,
I don't.
So, listen,
I would have said 0.
listen. 2 minus a -2, remember, is the same as saying 2 plus +2. If you would KCA it,
So you gave me money?
I forgot about that.
okay. -4 minus 2 gives us a
-6.
-6. Can I simplify 4 6?
Yes.
That becomes what?
-2/3.
-2/3. Where did that negative come from? Because I asked you to simplify 4 6.
Because I mean it's already negative.
That's the 6 in there.
Very good. So because we have a negative in my denominator, that negative can't just go away. But instead of keeping it in my denominator, I'm going to put it outside. Okay?
Did you really have to do like the top part? Can't you just like
This part here?
yeah, pretty much.
Yeah, you need to tell me where you're getting your data from.
Well, I mean, can't you?
You need to tell me where your numbers are coming from.
Well, this is pretty easy. You're in the guidance.
Yeah, I know.
I'm gonna be so confused. I'm gonna come shitty.
We're gonna do the work.
Jay's taking it.
Okay.
That's not
Guys, I want us to look at example 4b.
Just call it all out.
Shh. Example 4b.
Example 4. Yeah.
Example 4b, because this is where I gave you that heads up and we're kind of like, wait, what? So let's look at.
Heads up.
I did.
So.
If we look at examples 4b, it's on page 399. I have a point at 1, 3, and I have a point at 1, 0. So what is my change in y?
3.
Wait, what was it?
3.
I'm so sorry.
What are my two y values?
3 and 0.
1 and 1.
Y is
3 and 0.
okay.
Oh.
3 and 0. What are my x values?
1 and 1.
1 and 1.
Oh, I had a backwards.
0.
Okay. So what is 3 minus 0?
0. I'm at 3.
3. We're subtracting, not multiplying.
0.
What is 1 minus 1?
0.
Hey guys, is it mathematically possible to divide by 0?
No.
You just go equal 0.
Well, I mean,
So then, what is my solution? What is that slope?
It's 0, right?
Neutral.
it doesn't equal 0.
It is undefined.
Oh,
Equals
I thought that meant say, got my words mixed.
Listen,
Vocabulary.
listen. That means that the slope is undefined. Having something that doesn't exist
This is like having
and having something that is 0 are different. Look at the graphs in example 4. Example 4a, the slope is 0. That is a function. We have a horizontal line. Right, it has a horizontal line, it's straight across, the slope is 0. It is a function. In 4b that we just looked at, that is a vertical line. That slope is undefined. It is not a function. Does everybody understand the difference?
Yeah.
Yes. We're good?
Yes,
Okay. What questions do we have?
None. I feel like everybody else should have a question because I did most of the work.
Let's rephrase that to say you were louder than most.
Yeah. Yeah, I was.
Okay.
Yeah, I can't remember.
You're swearing all
That was
day.
so
I want a
fast.
cookie. You want a Nobel Prize. She's screaming.
Shh. Ladies and gentlemen, do we have questions?
No, ma'am.
Is he raising his hand?
All right. Thank you very much.